Hi, and welcome to my shop this morning. So with the replacement of the filter capacitors in the power supply here, I'm interested now, and I'm able now, to make reasonable tests of things like tube voltages and just other voltages that we could find inside the amplifier, plate voltage, screen voltage, stuff like that. And once I've gone through all that, and assuming it all comes out okay, which is a bit of an assumption, we could then draw the conclusion that everything is fine with this amplifier, and I can just move on to the radio. So this is kind of like a final check, if you like, on here. So I'm not sure how I'm going to video that. The next thing you might see is me just saying, "Oh, I'm all done." I don't think so, though. We'll see how it goes. Maybe when I find interesting things, if I do, then I'll flip on the cameras here. I don't know. Let's just take it one step at a time. Okay, so I've just barely got going here, and paralysis has set in once again. So the set is not turned on. Haven't turned it on yet. I've got the radio just back here. Just rearranged the stuff on my bench so you can see the voltmeter I'll be using. There's my leads. There it is. And then I thought I would turn my attention to a chart of information that's in the manual. That's where things kind of go downhill. So this chart is on one of the schematic copies that exist on the internet. This is the copy that has this condenser box, which saved me here. Now this looks kind of drawn in after the fact. This looks original, although it's been cut and pasted onto this sheet here. Somebody has tried to paste all the information onto one page. So let's just take a look at, first off, model R-32. And so I've got a model R-45 in front of me here. It's a different model number, but I don't think it's that much different really. Gives you the line voltage, and then mentions volume control position max. So in this radio, you can see it right here. The volume control is controlled by a variable resistor right on the antenna. This was a early way of doing volume controls, and the idea was you just feed in the amount of signal from the antenna that you want to come out of the speaker. Now in this radio, let's just take a peek at it while I'm on the volume control. There's a second volume control. I see the note here. Dual radio volume control operated by one knob. And there's the other volume control. And what exactly is it doing here? It appears to be just deadening or weakening this coil here. So it's almost like this is like a parasitic sink. It's going to suck power out of this transformer and dump it into the ground. So anyway, that's both of them are, by today's standards, pretty weird ways of controlling volume. But it gets weirder from there. So this chart looked great to me. I figure here's the tubes, radio tubes. Here's the amplifier tubes I'm interested in. 280, 245s, two 245s, and a 26. First audio amp, second amp. These are in push-pull, and there's the rectifier. So this is the set of tubes I'm interested in. And these must be all the pin voltages. And I was looking them over when my eye drifted up here. Oh, the title bar is complex. This is readings plug-in socket of set. And that seems to cover all these readings, just as you would imagine. But then when you come down lower, here's a subtitle, tube out. So it strikes me, you pull the tube out and you check with the tube out that there's 1.5 volts for the heater, 112 on the plate, I assume. You can come all the way down here. This is the detector with a very low plate voltage. So all these tests are done with the tube pulled out. I guess when you pull out the rectifier, you can't make this measurement here. So okay, so then what's this? This must be with the tube back in, but look what it says. Tube in tester. Tube-in tester. Readings, plug-in socket of set. Readings, plug-in socket of set. Tube-in tester. And I'm paralyzed at this point. So we look more closely at the chart now. So again, we'll start here. We'll start tube-in tester part. So you see it repeats the first two tests. Now you're looking at the tube voltage at the heater being 0.1 volt lower, I guess, because of voltage drop. A couple others are a little different. See the plate voltage dropped to 240 with the tube in place. That's how I'm interpreting this. Volts control grid. I think that says grid. So there's the biasing. 45 volts bias on the two 245 tubes. That's correct. I remember looking at that in the manual. Cathode heater volts. For some reason they've got this all dashed out. I don't know why. Why would you read it again? You read it. Volts control, well, cathode. Well, there's no cathode. Well, there is a cathode. There's a cathode on the 227. Am I mistaken? There's cathodes in the 45s? This looks like original or nominal, maybe it says nominal plate milliamps. So this would be the normal current just flowing through the tubes. You can see the signal tubes have a relatively low current of just a couple milliamps, but the powering tubes, they have a heavy current flowing through, 28 milliamps. Plate milliamp grid test. What? Plate milliamp grid test. I don't know what this is. I don't know what this is. Plate change milliamps. What? So what's going on here? Tube-in tester. This is some kind of tube test that's going on here. It must be. It must be more. It must be more said about this chart somewhere. But maybe that got cut off in the process of creating this page, cutting and pasting. The last one is screen grid volts, and they're all just nothing here. So why would that be? Maybe the 245s don't have a screen? I don't know. I think the 45s. Let me look while we're staring at that chart. I'm just going to look it up quickly in my book here. 45s. Oh, really? There's nothing to this. It's a triode. Sure, it's a 4-pin tube, Jim. Right. Of course, there is no screen. Okay, that settles that. All triodes. That's right. These are 4-pin tubes. And we might as well take a look at the 227. That's a 5-pin tube. It's got an extra pin. So it has some extra glory inside there of some sort. Could it be a screen? Let's just take a look at tube number 27, Jim. What are you doing? I'm sorry, I'm making you listen to me mutter here while I not so quickly find the page. Here we are, 27. It's the same thing. 27 is a triode. What? Well, okay, massive confusion floating around now. I don't think I can use this chart directly. I just think it's something to do with putting the tubes in some kind of tester. Some kind of tube tester. So maybe if I read a whole bunch more stuff, I'll come across where this chart really comes from. But offhand, now is there a reason why I just can't go through the set and just check these voltages and look in my tube manual and verify that they're within the range and all that kind of stuff? And I already know that according to this chart anyway, we can expect similar volts, if you can believe this chart, on all these tubes. That's in the radio though. We're not doing that yet. We're just down here. and the whole thing works anyway. Okay, so is that enough talk about a chart that doesn't seem to make sense? I think that's enough. Well, when I encounter situations that aren't making sense, I really doubt what I've got in my head. The first thing I think is, well, there's something I don't know, something I've got confused in my head. If things don't add up, I don't immediately assume what I'm looking at is wrong or something like that. So we could just try poking around at some of these voltages here, why not, and see what we find. And what I would want to know is, well, we'll know when we test voltages which one of these is plate and which one's grid. So I can use this meter for most of the measurements to the chassis, but anything other than to the chassis, I think I'm going to want to do something else. I want to make a good connection to the chassis. Here's one right in the middle here. Not going to go anywhere. Doesn't matter if it touches. Good, that's good and solid. Make sure this is flipped on DC. They put this on DC. There's a resistor inside here that's brought in series with the tip. And this just isolates away or makes the meter draw less current. And then the meter is calibrated for this resistor when it's on the DC scale. That's what's going on there. Okay, I think we can switch it on. Power's in. Switch is off at the moment. Okay. Turn the volume down. Now it's not on yet. Just in case there's excitement. So we're going on with the dim lights. Everything looks just fine. She's a full. So let's get our meter going here. What's that popping? You know, I've got this thing operating with the tubes on their sides. If you quickly look at the tubes, which I just did, and these tubes are not really meant to be operated on their sides like this. But if you're going to operate them on the sides, you want the plate structure to be like this. You don't want it like that. And the reason is the filaments are held a little better in this angle. You can see the plate structures inside the tubes there. You can see it. They are vertically. They're this way. So consequently, we're okay to operate this way. Wouldn't want to shake this thing hard though. You never shake this thing hard. Well, the crackling went away. So my guess is that's a tube pin moving, something of that sort, but I really don't know what it was. Let's just make sure it's operating. There's no antenna on it. So I will be the antenna. There we are. Of course I'm a useless antenna, but it's all working. So turn the volume down. DC plus. So on these tubes, a pretty high voltage, especially these output tubes. So we're going to set my meter to 500 volts full scale here. And we're going to guess, the two output tubes will guess one terminal is the plate. Eeny, meeny, miny, mo, I'll guess this one. Hey. Nothing happening there. How do you figure that? Okay, so that's the grid. So the yellow one must be the plate. There we go. So on the 500 volt scale, that's a mighty 350 volts. Here comes the crackle again. Okay, let's investigate the crackle a little bit. Well, it's here. The opportunity is presenting itself. tubes. No, on the volume's turned down, so it's a little hard to see how anything going on in the radio could cause this, but it could if it's affecting the power supply voltage. And these tubes are pretty solid in there. That's me tuning it. It's ready to pick up stuff. Ah, maybe it's this. I don't want to flip this other switch because it makes the speaker pop still. Oh, I don't know if it makes the speaker pop, but I don't want to risk changing to phono radio because the last time it made the speaker pop very loudly. Well, that didn't prove anything. So we don't know where those pops are coming from, but I don't like it. The B plus may have jumped way up when I did this. It may have. But a higher B plus may cause other components now to act up that weren't acting up before. Son of a gun. Really not a lot I can do about that. So I'm listening very carefully to see if when the clicks occur, if the radio quiets at the same time. Let's drop the overall operating voltage. I'll just put the dim lights back on. This will have dropped the B plus way off. So the B plus now is at, it's under 200. The radio's gone silent. Could be because some of the tubes are in cutoff now. Let me turn it up here. And I'll be the antenna again. Nothing. So I've just killed the voltage. It's 68 volts supply to this now. That's too low. I need to screw a bigger light bulb into my dim lights. Because it's gone quiet, but I think it's gone quiet because it's really gone quiet. If I get another light bulb, I could raise the voltage. Let's do that. Let's experiment with that. So I'm going to kill the power here. I have to go find an old style light bulb. How do you like that? I have a, sorry, just yelled in the microphone. I have a spare bulb up here already. A 100. Okay, so I went and found a 60. Keep a 60 up here. We'll put the 100 in. The one I took out is a 25 watt bulb. So I think that's 100 and I think that's a 60. It could be two 100 watt bulbs in there. Okay, keep the camera where it is and we'll turn the power back on through the dim lights. That was interesting, wasn't it? So the reason the dim lights didn't come on at first is something else was acting in the same way, only even stronger, and I think it's the light bulb in here. We should have a little more voltage now. What do we got? 84 volts. 84 volts. Is that enough to bring it to life? Remember, we're hunting down, we think we're hunting down the source of popping. I don't hear any popping. Volume is up full. Still not producing sound. That's kind of surprising. Where are we at here? 84 volts. Oh, I heard a pop. Okay, I'll view the antenna again. Careful what I touch. I hear some popping and clicking. Don't know if it's me or if it's the radio on its own. Well, maybe 84 is just not enough again. Let's give it full power here. Oh, just about instantly. That's a lot of... Where did that come from? Okay, back down. It's interesting, the moment I turn it down, it goes away. Up. Down. Wow. You kind of expect it just to get a little quieter, or maybe click a little less, not just go totally away. Both my light bulbs look identical, so I'm pretty sure they're both 100 watters. That's as little restriction as I can provide. I'm stuck either between 80 volts and 120 now. No, there was no noise like that. And I tested this radio yesterday after doing the capacitors. There was no noise. What's different is this thing is up on its side. Really? Having it up on its side? Well, you know, not knowing what's going on, I'll have to put this back down and test it. I just have a little bit of trouble believing putting it on its side would cause that, but I mean, let's see. The other things I did was I unplugged and replugged these connectors. So maybe the connector's not in all the way. Well, it is not in all the way. I know it's not in all the way. Let's push it like that. Just looking at how I can tip this without straining too much wire. Like that. I think it's going to pull it really tight. Okay, I don't like pulling this plug in and out all the time, but let's do that. Bearing in mind it could be the plug. Maybe I didn't get it. Maybe I really didn't get it in all the way. So what's going to happen is I'm going to tip this flap. The clicking, popping is going to go away. I'm going to say, oh, it's from having it on an angle. Meanwhile, it's really how I've plugged this plug in. It was about like that. It's still sticking out just a little bit. Okay, man. Here we go. Dim lights. That's really interesting. Yeah, this thing's own dim light is doing the trick here. Yeah, can that light bulb really work as a dim light? I'd say it's off. It's off a secondary on the transformer. No, I don't think so. No, it cannot. It's a really interesting question about, well, why is this? Why does the power come up like that? Okay, so we have a total of 84 volts again, and I don't see any of the heaters here. They're on, but like this one is really dull compared to this one. There's no popping. Full power. And she's a popping away. Oh my gosh. So this kind of stuff is really hard to sort out. Where did it come from? I'm sure I didn't hear that when I tested this radio yesterday. Paralysis in the shop here. That's what this amounts to. So what's going through my head is,
Can I continue to operate this, or is whatever it is that's failing about to cause a really big problem in itself failing or taking something out with it? And what would that be? One of these transformers. That can't happen instantly. It takes time, you know, unless there's a nuclear event here. I should be able to operate it for quite a while, actually, before something really gets hot. There's nothing hot here. I can't get hot. There's nothing really hot here. Oh my gosh. What do you do in a situation like this? So it would be good to prove whether the noise is coming from the radio or coming from here. I'm trying to remember what the volume control did in terms of the noise. I can't remember. Back on we go. Volume control has no bearing on it. Power off. We're going to take out the first audio tube here. Power on. Slowly. That seems to have settled it. Plug this guy in. Last tube over here on the receiver, the one that would be sending. Don't know which one it is. Let's try one. So it looks like the problem is, I don't know. Let's check this. Hey, that seemed to settle it down. Quieted down. What happened? What exactly? What happened that settled it down? This thing? Come on. Doesn't seem to be caused by anything loose. That's kind of disappointing. Well, it's gone away. So, okay, I fixed it. Now, we'll get back to what we were really doing here. Okay, power off again. Jeez. I don't like switching it on and off so much. Up you go. Go. Everything's good. Oh wow, that's they need to practically put a tool on this gigantic plug that's going in here to squeeze it in. Okay, do you think we're ready to start? Back to getting the meter set up. Okay, the thing I got to keep in mind is that all my equipment is now power outlet grounded, so to speak. So I have to be a little bit more thoughtful when I'm putting these on. Just a little more thoughtful. Don't have to be fully thoughtful. Power on. Any popping? It's a mystery. Now I've got this tube number 1 is not plugged in all the way. Just noticed. Okay, it's in. That was kind of odd. Okay, carrying on now, ignoring the clicking at this point, just moving forward here. 500 volt scale, plate voltage on a 245 is 350 volts. That sounds a little high on a 45, so we'll quickly flip to number 45. And the answer is 45. This shows a plate voltage supply 275 volts maximum. Huh, maybe that's where this noise is coming from. 245 maximum. 275 maximum. Plate supply 45. Quickly, anything else? Grid voltage supposed to be, wow, it should be like minus 50, almost 60 on the grid. Cathode bias resistors value, plate current 31, we don't know what it is because we can't measure it in here. La la la. Okay, what is happening here? The set has a gargantuan voltage on the plate. 350. 350. How about this guy? Okay, so that's the first audio tube, why you can hear it. Now that's a little more in the range. That is 125. No, I'm sorry. It's 110. Well, 125. I'm seeing double there. 125 on a 26. That sounds a little more normal. 125 on a 26. Number 26. There it is. Filaments. Typical operation is Class A amplifier. Plate volts 180 max. Grid voltage. Now this might make some noise. I don't see anything there. Plate. Grid. My meter a little more sensitive. I don't know what to expect on here because the grid could easily be at. There's nothing showing up there. So we know the 45s are supposed to have a big negative grid voltage. So we're a 50 volt scale on this meter now, so it should go right over when I do this. Hey, what's happening? So I'm reading to the chassis, which may not be the... Okay, so far we got a whoppingly high plate voltage followed by a non-existent grid voltage. It's not very good at all, the way I'm measuring it. We should really measure from cathode over. The problem is I'm not going to do it with this meter because this lead is grounded. So I'm going to do it with this. Much safer way to do this. Put this on, we're looking for something like 45 volts, 50 volts, using my teeny tiny leads. You know, when you hook up one lead from a voltmeter, the other lead is carrying the voltage right away. Be smart to hook this up to the grounded side of things first. And we're going to look from the, basically, use this hand here. Basically, from the heater, can you see the reading? To the grid. There's the 50 volts right there. Okay, that's good, that's good. Let's measure from the heater to the plate. What do we get when we do that? We get 300 volts. Negative because my leads are backwards. Careful, man. 300 volts. Careful, 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 careful. You know, I'm sitting here holding this meter. I'm wondering, are there any screws sticking out in the back of this? Yeah, that I would be touching. Well, so I think my reading here is kind of bogus. Bogus by 50 volts. Well, that's interesting. Now that 50 volts. That 50 volts is exactly that. You know, I'm reading the combination of. You could think of it as the combination of the grid bias and the plate voltage to get 350. So 300 is still pretty high. I'm going to guess the 300 is there because of these fresh capacitors. Before that, I'll bet you it was more like 200. So, now, is that why the popping was happening? It's quite possible. If you, it's quite possible. You could have these tubes. There could be a problem in one of these tubes. There could be a little bit of a leakage path inside between the elements. And it's not really brought to life until you raise the voltage high enough and start getting the discharges in the tube. Whacking the tubes would probably reveal that. I whacked all the tubes a little bit, didn't hear a darn thing. Just reviewing my confusion here. Okay, so is there a problem here that needs to be dealt with? These resistors may be implicated. So let's see where they hooked up to. This is going from, well, this is the grid connection here. This is a grid connection here, and likewise here. So in a push-pull arrangement, what is a grid resistor doing there? Let's take a look at the schematic again. I'm not trying to say there shouldn't be a grid resistor there. It could just be I'm a little clueless. So this must be the grid resistor we're talking about. It's R9. And I remember now there's an R9 here. So this is on the grid of the 26 and on the grid of the 245s. They're all R9. And now R9, I know that I've done this already. I know this isn't. Oh, let's just make sure we're down here. R9. Whoa! Oh yeah, 0.5. It's the same up here, isn't it? Yeah, 0.5. So 500K. We expect 500K resistor in the R9 position. The three of them, they look identical when you look at them, and here they are. Now, if I try to read the resistance of these, I'm in trouble because I've got the coil right here. So how would I figure out the resistance of these? This one's in the same spot. I have to open them. Open the circuit, measure them. It's really the only way. I think that's the only way. Okay. I'm going to measure them with the power on. Kill the power. Before I take them out of the circuit, I'm going to let this guy take a run at them. This is not your ordinary meter. So it may use frequencies to determine the resistance of this stuff. It's such a busy little tester. Maybe it can test them in circuit. Oh, it says it's a capacitor. Damaged part. Yeah. Okay, so that we can't do it here. There may be a little residual voltage setting on it too. If I just turn the set off. I don't think that's going to work. So if I'm lifting one leg of these resistors, I'm halfway through replacing them. So that's probably where this is going to end up. Replacing these resistors. So that being the case, I could clip them all off. Why don't I clip them off the ground terminal in each case, or this, not the ground terminal, whatever this is the grid. Clip them off the grid. Let's do it. Let's do it. The only way to be absolutely sure. Lots of wire here, I can solder them right back on if I have to. One. Two. Well, these are all supposed to be the same resistance, but I can tell you they don't look the same. This looks skinnier. This one looks skinnier. Now we'll test it with my oh so reliable meter here. What do we think these are? What these were half a meg. So I'll put on the 2 meg scale. Previous testing of these resistors in circuit, I've done it a couple of times, sometimes off camera. It didn't reveal anything particular. Okay, so that's 400. I better write this down. 430. It's a little low. 430. I need a piece of paper here, come on. $430. Okay, next one. I wouldn't normally expect these to go low. I expect them to go up. Or 79. These are, and my experience with these resistors, by the way, has always been very good. Oddly enough. This style of resistor. As ugly as they look. Look at that. Look at that. Right on the money. I wish I could have figured that out without cutting them off. What to do now? Should I put them back? Leave them original? The answer is yes to that. Good question. They're all in pretty good shape. You can't be responsible, I don't think, for even the one that's 450, 430, 430 instead of 500. So these are in push-pull. And they're looking for things to be balanced. I have 2 resistors here of different voltages. Surely that can't be balanced. Also larger resistors for, I guess, for wattage, maybe. Oh, that's so close. 480. This one here is the one that 430, 480. So why don't I replace this one? Oh, you're all yelling. Place them both, man. Why not? Okay, 2 brand new half meg resistors going in there. Okay, so I've got the 3 resistors installed, and now we're going to get this radio test here. Everything ready to go. I'll just remove this. Okay, because we're going to be using this meter here. All seems normal. Okay, full power. Which is, oh, there's that static again, 121 volts. So I'm going to test across this 500,000. See, it's much stronger when you first turn on the set. This way, this way, this way. This is on 45. It's kind of not quite what I would expect. 200 volts DC. Okay, let's look at the plate voltage. On this meter, we'll get an accurate reading here too. Plate voltage. Plate voltage to the chassis. 350. Plate voltage relative to the cathode. 300. So 275 is supposed to be the limit on this. I'll try this on this too. Try this guy. Okay, almost exactly the same, which is a good sign. Now, we'll read the grid to the cathode. Should be negative. Let's try that again. Heater to, there we are. 50 showing negative. Excellent. Now this one. 50, very same. That's great. Bias on the first audio. Ooh, what was that? Was that me? Ooh, how do you like that? I think I found our problem here. -8. I think that sounds right. -8 on the 26. -8. So quickly. 26. 26. Typical, let's see, plate volts 180 max. The grid volts -14. Wow. Okay, -14 for 180 volts. -14 for 180 volts. So the plate voltage, okay, 124, so it's not 180. Grid -8 instead of 14, that doesn't sound too bad.
What's that silly chart say? Just going to take a peek at it for what it's worth. Mr. Chart, what do you tell us here about this? 227. 52 on the plate, not 120. 52. Okay, I'm going to put this up on the screen here so you can take a look at this too. Okay, so the chart sideways here on the 227. 52 on the plate, and we're getting quite a bit more. Two volts. Oh my gosh, only that looks like 2. Or is it another 8? Looks like 88882 6. 2 sounds a little low. 44. Yeah, 52 with the tube pulled out, 44 with the tube in. We're getting something much higher. So what's restricting the plate voltage? Let's look at the right schematic too. So this is the 227. There's the plate. Ooh. And yeah, I don't see anything really restricting the plate voltage here, like a resistor. Other than this coil. Yeah, I don't see anything. Way over here? This guy? R7? Somewhere in here? Oh, that big resistor. We gotta investigate that big resistor. That's where we're going next. What's going on with this gigantic blue resistor? Okay, let's take some voltage readings on it and see what they are.
One end of this is probably, I think the ground is right here. Yeah, actually you can see the connection. So they're grounding it in the middle of this voltage divider resistor. So this point is actually negative with respect to the chassis. It's a trick, I tell you, it's a trick. So we'll go from the ground point here. Should we? No, we'll start right down here. Let's start right down here. $50 volts. 40 volts. 8 volts. This and this. What? So it must be ground point, main supply point, voltage dropping. Chassis voltage. Just puts this point 50 volts positive to it. This point is 150 volts positive. Okay, so this is really, as usual, I'm getting thoroughly confused. Shouldn't this be like 300 volts up here? Shouldn't there be 300 volts on this thing somewhere? If I can find 300 on the plates here, why can't I find it on that resistor? Back to the schematic. So the high voltage out of this just ignoring that, can't ignore it. I'm going to make use of this opportunity here. Where'd my stick go? What can I do with my stick? Come on, give me a stick. Hurry, man. Could be these guys. Did that seem to work? Let's have something a little more direct here. This is the tone adjustment. And this is the something else adjustment. Oh, I like that. Oh. I think this is the guy. Jumper. What was that? think that was me. How could that be? Touching from here to here? Shorting this from here to there? Why would that do something? This is on a metal. Careful now. Accidentally short something. So I'm just trying to apply mechanical forces in various places. Where'd it go? All our noise is gone. Suspiciously similar noise here. Oh, this thing sounded like it went open circuit there for a moment. Okay, maybe that did it. Maybe that's where the noise is coming from. Back to what we were doing. Yeah, right. Maybe that's not where the noise is coming from. Can't chase it down when it's gone away. You might have to signal trace this to try to find the part that's really causing it, but can't find it when it's not there. Right, and it went away when I pulled out the audio in tube. It's either this tube or something else. I put a different 26 in there. Why don't we try that? Is there anything funny about that? Tube test. Find another 26. Gotta go hunting a little bit. Remember 45 and 80. That's it. Okay. Okay, what we're going to do, we're going to pull a 26 out of the receiver and stick it in here. Anyone in particular? This one. Stick this guy, this is a 26, just to be absolute 26. We're going to stick them in See what happens. Here we go. Live. Okay, so that proves a lot, doesn't it? Whatever it is that's causing this noise is ahead of this tube. Okay, so we're going to put this one back where it was. I don't normally pull tubes out of working sets. That's not one of my... Put this guy back in. As soon as it warms up, pop, pop, pop. Okay, looks like we're not going to figure that guy out this time around, where that static's coming from. Back to the resistor. So, do I have any information at all about the voltage we should find on the resistor? Nothing written there. Oh, cable terminal voltages. 185 volts. Well, these are strange readings, between 1 and 3, 5 and 7. So I'm reacting that there's no 300 here. How do you get 300? Must just be the way these tests are done. Well, I don't have any particular reason to be suspicious of this, but I don't have any tests I can really come back at it with unless I read the resistance. Now, can we read the resistance? Capacitor that way. Pull this plug out. Okay, that's good that way. Here, up to here, over to here, to here, through here. Pull the plug out and it's open. Okay, how about from here, over to here, over to here. Isolated circuit. Doesn't go anywhere. To the ground. And then here, this last one also goes to another isolated heater circuit. Doesn't go anywhere. So you know what? I can pull this plug out and I should be able to read these resistances correctly. And they are written over here. 7, 8, 9. Excellent. So that's what I'm going to do. I'm going to pull the big plug out and read this resistor. Okay, let's run down the big resistor here, and I've got the chart on my computer screen so I can read what the resistances should be. So this first, and on the schematic they've drawn it pictorially correct. So they've drawn the long resistor. This piece is showing longer than this piece, which is longer than this. So they've actually shown it pictorially. So we get a little over 2K, and this is R7, it should be 2K. Next one down. Okay, so this one is R6. R6 should be 1350. $13.50, right on the money. Huh. Next one is R2. R2. Where's R2? R2. 200 ohms. So this should be 200 ohms here. Look at that. Wow. And the last one, which reads 750 ohms, should be 775 ohms. R4. Right. So the resistor is beautiful. Thank God, because look at that thing. Isn't that a monster? Okay. So, well, I think that's it for today. So what we determined is probably nothing has been terribly improved in here by putting in these resistors, but we know these are right on the money. This is a balanced push-pull output. It's probably wise to try to keep these two resistors identical, whatever they are. And All that popping and clicking is driving me nuts, as you know. I don't know what to think of that yet. We have determined it's something ahead of. It's something basically on the grid of this tube. How's it getting there? Assuming it's on, yeah, it has to be on the grid of this tube. These tubes all sharing the plate, but they don't share their grids in any way. So, so something special is happening to that tube, I think. So thanks a lot for watching, and we'll see you on the next video.